On this video, I'm going to talk about testing. We'll see the different layers of tests that we can do to build robust simulation models. And this video will be divided in two parts. On the first part, we will discuss the different conceptual framework associated to functional tests. And on the second part, we will build a model from scratch that will allow us to build the whole infrastructure needed to build functional and unit tests in Anylogic. And we will build a model using the best practice that professional software developers use in order to use unit tests to develop very robust applications. So let's get started. A while ago, I had an interview with the Anylogic modeler, Jacob Voslo, and we talked about unit tests. On that interview, I said, I don't do it. And there are reasons for that we'll talk about on this video. I will leave that interview in the description if you want to see it. But first, let's talk about testing. How do you know that any of the features that you made in your Anylogic model work as you expect them to work? How do you know it? And the answer is testing. You need to test. So there are different layers of tests. There are two in particular that everybody is forced to do. One of them is the compilation one. So you compile your model, and if it throws an error, that means that there's something wrong. Another one is you run the model, and if it throws a runtime error, that means that you're doing something wrong. Those are the two tests that everybody is forced to do. When you already have a few months of experience doing models, you start doing the next step, which is you run the model, maybe you pause it, you check if your results are kinda on the direction you want. And I say kinda because when you build a feature and you check vaguely in the model what is going on, it's very difficult to see the implications everywhere in the model, in particular when you have a really big one. But this is something that people learn how to do very early on in their simulation career. Another test that people learn how to do very early on is to use the log, check the log, and see if the log makes sense according to what they expect. So you can do that in Anylogic very easily, and it works also, again, you don't know all the implications of changing a feature in all the elements of the log. So it's a good thing to do, but incomplete. A more advanced version of this log analysis is generating a customized log that you can then analyze using a script in R or Python in order to build different tests that check if the log is generating the data that you want. For example, if a pallet should be between 500 and 600 pounds, and your script checks and it sees one that is 400 pounds, it means that it will throw an error, and you will know what that error is, and you will go back and fix the feature. And also something you can do is generate a small model for the particular feature that you need in a different model. You test it in order for it to work perfectly under all possible conditions, and then you bring it back to your bigger model and you implement it there as an agent, and according to the logic of what you did, it should be a very solid agent that works perfectly fine. But now we are in the topic of this video, which is functional and unit tests. There's a formal way in which you can do these unit tests as a best practice, and it's the following. First, you generate an idea of the feature you want to create. So for example, if you have a model that sends men to one queue and women to another queue, that's your feature. Then you want to create a test for that feature. You haven't built any model yet, but you conceptualize this test and you code it. So the test will check if there's a man in the woman's queue or if it's a woman in the men's queue. And if it returns one person, that means that your model failed and there's something wrong with the feature you created. So this is the test. Once your test is created, then you start building the model until it passes the test or the multiple tests you created for that particular feature. This is difficult to understand when you hear this concept for the first time, but we will do that in detail in the model we create later. The most interesting part of doing all this is that you will generate a set or a collection of tests. So each time you build a new feature, it's not only that feature that will be tested, but all the features that you created in the past. Which means that if you make a feature and you break something that you did in the past that doesn't pass its own tests anymore, you will get that information and you will be able to fix everything immediately. So the question is, why are these tests not a general practice among simulation modelers? Why are we not doing it? And I think the main reason, and it's the reason I didn't do it in the past, is because doing them takes way too long. Building tests for your features takes a long time compared to not doing it. So when you do a small model, it's debatable if it's worth it or not, because a model that takes 1 hour to build, a small one, that is very simple, and when you do it without testing, takes 1 hour, it might take 10 hours if you do testing. And that doesn't guarantee that you have a better model. Nevertheless, if you have a model that takes 6 months to do without testing, it might take 5 months with testing, because you are betting on saving time on all this debugging situation that happens, in particular in big models. So you can say that you get more benefits on doing unit and functional tests as your model size and complexity increases. It also works the same way when you work in a team. The benefit of using unit tests and functional tests increases as your team size increases, because when many people are working in the same model, you don't want someone else to break the feature that you did 3 months ago, or vice versa. And unit tests are the best way in order to be able to save that situation for happening. Another question is how much to test. Building all the possible tests that can exist is infinite time. Like, it takes way too long. So you need to choose very carefully the things that you want to test and the things that are too obvious to test. So you need to spend time testing the right things. And this is the trade-off between testing and speed of development. So this is something you only learn by experience, I guess. Another thing that is very beneficial by doing unit and functional tests is that you are forced to think beforehand about what it takes in order for your feature to work. So what are the implications of your feature? How does your feature test against what you expect? And this is something in general modelers don't do at all. They just build models as puzzle pieces without thinking too much about the implication of anything they're doing. Unit tests, and in particular the best practice about doing the test before building the feature, is a significant improvement in the way we face the models and in the way we understand what we're actually doing. Now, there's another way that you can use, which is not the best practice, but it's still possible, to first build the feature, and after you build the feature, you create the test. This is not the best thing to do because you have a bias when you do that, and you don't maybe develop the tests as you should because you're biased by already having developed the functionality. So this is not best practice, but a lot of people who do unit tests, even professional developers, they still do it because it's too difficult to build the test before building the feature. And it's not very fun. It's much more fun to build a model than to build tests for the model. So you get bored pretty fast by doing tests. Okay, so with all this being said, it's time to build the model. Now, the model I created is very simple, extremely simple, but the tests are very exaggerated. So I'm building all the tests that I can think of, which are only 3, and you will see how I think about it and how I do it, and this will give you some inspiration in order to build your own models and decide if you want to do unit tests and functional tests on your own. And there you go. Let's get started with that. So what we're going to do is use this very simple concept just with the purpose of using unit tests to test different things. So the model will be passengers arriving to a queue and then they will be scanned. That's it. No resources, nothing complicated. That's all we want to do. So we care about a few inputs here. First, we have the passenger input rate with an average of 10 and standard deviation of 1. And we have the scan time, which takes 10 in average with a standard deviation of 2 and a minimum of 2 seconds. So this is all we care about. Let's get started. So to start with this model, we'll just add all the parameters that we need. So I will add, for example, the passenger arrival rate per minute. This will be a rate per minute, and what we say is 10. We'll have the passenger arrival rate standard deviation. This will be time, 1 minute. Then we have the scan time. This is time, seconds. What they say is 10. The scan time standard deviation also is seconds, it's 2. And the scan time minimum, also 2 seconds. So this is all we have in the model. Now, what we want to do before even starting the model is to have a test that is ready in order to develop a feature, and we will use the test in order to see if the feature works or not. So the first feature we want to do is just a simple arrival. Very simple. So how do we do that? We need to construct our framework. And to do that, we need several different things. The first thing we need is a data object. Let's call it general data, and it will have everything that is an input to the model. So let me do that quickly. Okay, so here we have everything. This is our data object with all the information that will be an input on the model. But I actually forgot one. So there we are. We will use this data object in order to generate different scenarios for our tests. So let's add this data object in main. This will be of type general data, and it will take, and the initial value will be a new instance of this general data. And it will take all the parameters that we have here. And there we are. We have our data object ready to be used. The second thing we need is something that collects our information. So kind of a stats object. Let's create a new one. Let's call it model results. And this will hold our results. So the first thing we need to test is that the arrival rate of however we're doing the arrival rate is aligned with the average and the standard deviation that was provided by the requirements. So in order to do that, we can collect the amount of arrivals during the model runtime. So let's call this public int passengers arrived, but actually we'll make it private so we can create a getter and a setter. So let's do that quickly. Okay, here we are. We create a getter that just returns the variable, and a setter which adds 1 into the variable. That's it. We don't need anything else for now. So the third thing we need is a scenario object, which will hold all our data objects in order to generate different kinds of scenarios. So let's create that. So this will have public general data GD, and we will create something that will add information to this general data. I don't want to do it in the constructor because I might be using different data objects and I want to add them according to my needs. So let's add something here. Okay, so now we have this little function that puts a value in my variable here. I will keep it public for now, doesn't matter. So let's continue. We have our scenario now that is doing nothing. The last thing we need as objects is the test. So let's call this unit test. This class will hold all our tests that we want to do in order to see if our model is working or not. But we don't want to reinvent the wheel here. So what we're going to do is to use JUnit, which is the standard library Java developers use in order to develop unit tests. So we're going to use this. The first thing we need to get started is to download and install. So what we will do is to download these two jar files that we have here and add as dependencies of our model. So you can go to the model properties and just add them here. So I have them here already. So let's go back to JUnit, and if you go to frequently asked questions, there's a template that they have in order to get started. So you can just copy paste here, and this will allow us to use the JUnit and also all the assertions. The assertions can be found here. There's a bunch of things you can do, like compare it to another value or checking if something is null or not, etc. So we will do that on this video. So let's go back to the template. In order to use the template, in order to create a test, we need to use this test annotation and some function that uses one of the assertions. So that means that here we can just write test, this annotation, and this will make the next function that we write become a test. So we'll do public, like we can use assert true, and in here we'll put the message that we want. When we get an error, you can define a message. So we'll write arrival rate doesn't match, and the comparison we'll use true for now, but we'll need to use a comparison here. So in order to do this, we will need to run a simulation, obviously, and the simulation needs to take as an argument the scenario that we want to use. So how can we do that? By using a custom experiment. So let's add a new experiment, custom, and it's a tester. Now, in order to use an argument, which will be the scenario, in the tester, instead of using the code here, as is generated by default by Anylogic, we should use the additional class code in where we can create a function that will return a value. So what we're going to do is to use public main, so this will return our main, run sim, and we'll add some stuff in here. So what do we want as an input? First the scenario, and maybe the simulation time. What we can do here is have main root equals new tester dot run sim, and this will take two things here, the simulation time and the scenario. So let's create the unit test with the scenario in it. So here we can put scenario.simTime minutes. So we can define this arbitrarily to be 10, for example. So this is in minutes, obviously. Okay, so if I compile it, I have an error because I'm not returning anything. So I can return here root, which will be our main. So I can copy from above. Also, I need the engine, and I can set different elements here. So let's copy all this. And for the default random generator, I can create a new random. Next long will generate a random seed. We can start the time at 0. And at the end, we will need this as well. We'll also need to set a stop time that will be equal to the sim time minutes. Now, we need to initialize all our parameters. So let's do that. Root.set, for example, arrival rate per minute. This will be the scenario.arrival rate per minute. No, the scenario.gd, I think I called it, dot arrival rate per minute. So let me do that quickly with all the other inputs. And there you go. I have all my 5 parameters initialized. Finally, we can do this. I don't know if it's necessary or not, but let's do it anyways. So our general data is equal to this, but this is already initialized, so it should work anyways. Okay, so everything should be fine here. The next step is actually to run this. So we can actually put a button in the simulation and run it from there, but I think it's easier to just create a new custom experiment. Let's call it run all tests, and we can erase all this bunch of code that we have here and just run this test arrival rate. Okay, so let's go here and let's create a scenario. And on this scenario, we will need a general data object, right? So general data. So now we can put all the inputs here that we need: passenger arrival rate, passenger arrival standard deviation, scan time, and all that stuff. For this test, remember that we only want to test the arrival rate distribution. So we can put here 10, which is the mean, 1 is the standard deviation, and the scan times, we don't even care. Now we can easily add to our scenario the general data object here. Let's call it GD. And finally, we'll create a unit test object equals new unit test. And this takes the scenario as an argument. And from here, we can just run the test arrival rate. So this will run this function. We'll come here and we'll run this. And we have to check something here, right? We have root, so we have the results of the model. So we can use root.model results. Oh, I didn't put it yet. So in here, we should add the object model results, and is of type model results. We can just use, and now we go back to the unit test and we can use this model results dot get num passengers arrived. And since we know that the mean is 10, maybe a bad thing to do would be to do just, for example, get number of passengers arrived equals to scenario.gd.passenger arrival rate per minute. multiplied by the sim time minutes. We can do this. Even though this is wrong, obviously we will never have this, exactly this equals to this. It's impossible. So what we can do here is actual equals this, and double expected equals what we have here. Just to make it cleaner. Again, we can trace ln actual and expected, just to be sure that everything is fine. So we can run all tests, and what will happen is that we have an assertion error. Arrival rate doesn't match. This is the error we get because the actual is 0 and the expected is 100, 10 per minute. So this is not working. Obviously, our model has nothing. Our model is completely empty, so this will obviously not work. And this is what we want. We want to create a test that doesn't work first, and then build the functionality, and the goal is for the functionality to pass the test or tests that we created. Okay, now is where things get quite advanced. Because how do we do something that is actually testing a distribution here? And what we can do is run 100 simulations and compare the average with what we expect. For example, with a 95% confidence level. So let's do that. So I will run this 100 times. I will get the expected and the actual. And I will do an int that will count successes equals 0. And what we want is to count successes to be above or equal to 95. Out of 100 simulations, I want 95 of my arrival rates to be within a certain range. So the question is, what is that range? So from statistics, we know that the actual value should be between two values that represent the 95% confidence interval. So it's the mean minus the standard deviation divided by the square root of the sample size. This should be lower than the actual, and this should be, and the actual should be bigger than this mean plus the value. And I forgot the z value for 95%, and here as well. So the mean, we know that it's 10, but we can grab it from here. Scenario GD dot arrival rate. And let's forget this for now. So we can just use this. The z value for 95% is 1.96. You can look at that in a z table. The standard deviation, if we assume a Poisson distribution, should be the square root of lambda, which is this. So we should divide this with n. Since we're running for 10 hours, we can assume that we have 10 samples. So sim time minutes. So what we do is, if the actual is bigger than this, and also actual is smaller than this, then we can count a success. So if this fails, we want to know why. So arrival rate doesn't match, so expected is 95, actual will be count successes. But I forgot something here. This should be divided by sim time minutes because we want the average. So this is the actual. So this also will be the exact value. Now I'm not confusing here. Remember that if we assume a Poisson distribution, the variance and the mean are roughly the same, and we can assume the behavior similar to a normal distribution. So this is not a mistake at all. Okay, so we can run the test and we fail, expected 95, actual 0. Okay, so finally, after all this time that we have spent setting up all our tests and generating this test arrival rate, now we can finally run the model and see if it does what we want it to do. So this is such a simple model. We will create a source. The arrival rate, will use the general data, passenger arrival rate per minute. Here we use per minute. And we can add an agent type, passenger, even though this will have no implications whatsoever. And we can add a sink. Finally, on the sink, we can add model results dot add passenger arrival. This will increase by 1 the number of passengers arriving. Now we can run the test again, and it fails, expected 95, actual 93. Let's run it again, and now it passed. So when it passes the test, we have nothing on the console. At least we didn't ask to get any output in the console. So we can assume everything went fine. But we have a problem because the 95% is kind of a risky, the 95 successes is a bit risky. But there's always a chance that it will fail. So I can arbitrarily put 90 here in order to check if my model is doing the right thing. And I think it is. Generally, it will pass. So if it fails at any point, I can check, like, why did it fail? And if my answer is that there was 89, maybe I can recheck, or maybe there's something wrong. Now, if you remember, the passenger input rate, it had an average of 10 and standard deviation of 1. I completely ignored the standard deviation because my assumption is that this is wrong, because you cannot have an input rate which follows a normal distribution with an average 10 and a standard deviation 1. This doesn't work. But people did this mistake. If you check my previous video about this model, and what they do is the following. Instead of adding this value here, they will generate a normal distribution with this, and you need to put the sigma and then the mean. So general data dot passenger arrival standard deviation, and here general passenger arrival per minute. So this would be what someone would do, because they see that this seems normal and they put the normal distribution here. And they continue the model without ever thinking again that this might be wrong. But let's see what happens. But we need to modify our test a little bit, because now the standard deviation is not this anymore. So let's save all this, and let's add another one that works for the normal distribution. And instead of this, we'll put a 1 here and multiply here by the standard deviation. Now, let's run it. And it fails, actual 30. This actually fails all the time. 35. So this is an example of something that you normally don't even test. This is so freaking simple. And the fact that you put a normal here, which seems okay, actually, if you run the model, but let's first put here only 10 minutes, which is 600 seconds. Let's run it. And you will see that you expect 100, and this is pretty close. So you run it again. Let's change this to random seed as well. So you run it 103, you expect 100. You run it again, 88, seems pretty close. Like if you test like this, you say, oh, it's pretty close. Like it must be okay. Yes, I think it's okay. But this unit test that we just created with such a simplicity of a model, it just doesn't pass. So it sometimes works 36% of the time, but it doesn't pass our 95% confidence interval. So what do we do here? We have to go back and rethink what we're doing here. So the problem is that this is not a normal distribution. It cannot be. It just doesn't work. So we can go back to our Poisson distribution. Because if you put normal here, it's a Poisson of a normal. It's not even that, it's a Poisson of the sample. It's the Poisson that takes as an average a sample of the normal distribution, which is not what we want. So we can go back here, comment this, and enjoy how our test now passes without any assertion here. So we finished the first part of the model, making a source that makes passengers arrive. That's it. Now let's create another test. And by the way, I made a mistake. I didn't change this to passenger, but this wasn't my test, so the mistake was not identified. But we will create the model that allows us to move the passengers from an initial point to the beginning of a queue. So in order to start going to the scanner. So let's add our animation with a point node in the entrance, then a path towards the destination. So let's call this scanner node and entrance node. So again, we did this. This doesn't matter so much, but what we want is to do the test before we do anything. So in order to do this test, we will inject a number of passengers into the source and see if after a while I get the same number of passengers in the output. So what I want to use is the limited number of arrivals. So let's add a new parameter here called max passenger arrivals, and let's make it 0 if it's unlimited and anything else if it's not unlimited. So we'll add that to our general data object, and there you go. Now we will need to generate this with an additional parameter. So the default is 0. So we'll probably have another error in here, the constructor. We don't even care here. But this is it. So again, we need to collect some model results, which will be private int num passengers arrived scanner, and we'll create the getter and the setter. So very simple. The getter just returns number of passengers arrived to the scanner, and the setter just adds 1 to these passengers. Now we can go to the unit test and build a new test. Again, we need the annotation here. And here we have the scanner arrivals. Again, we can generate 10 minutes of simulation, should be enough. So we can run this. And we can again assert true with a message arrivals to scanner don't match expected. And the expected here is scenario.gd.maxArrivals. We can erase this, and our test will be scenario.maxArrivals equal root.modelResults.get num passengers arrived scanner. Now we need to go back to run all tests, and we'll create a new general data, but this time we'll add 4 here. So we'll create 4 agents as a maximum. The scenario will set the general data, and then we will create a new unit test with this new scenario. And finally, we'll run the test. Test scanners arrivals. And that's it. So if we run all tests, there's a problem. Because arrivals to scanner don't match expected 4. But we didn't add maybe another message, which is the result of this actual, and we will show how many arrived. So actual 0. Obviously, nobody arrived because the model is not done correctly. So let's go back to main and let's create the model. What I'm going to do is to add a conveyor here, because I like to use conveyors instead of queues. Queue to scanner. And I will need to change this to be executed on exit. And finally, at the end of the scanner, on exit, we will add the results of this. Add passenger scanner arrival. Now I need my passenger here to start in a particular entry node. We'll ignore the speed, doesn't matter. And this will convey in the path here. And that's it. We can actually run. This will get an error probably, because the agent is not able to leave the port because there's no space. So we need to add a queue here with maximum capacity. And now we can safely run again. But the arrivals scanner don't match the expected value. 114 arrived. Awesome. So I need to make this work. So in here, in the source, that means that I have a limited number of arrivals. So let's limit it based on the max passengers arrival. So if the max passenger arrivals is bigger than 0, then this will be true and the arrivals will be limited. If this is 0, then they will be unlimited. We can put the max passenger arrivals here, but we don't want to use the parameter. That's a mistake. We use general data dot max arrivals, I think it's called. Okay, let's try to run the model again. We still get an error, and why do we get an error? It's probably because on the tester. So first, I should have deleted this code a long time ago, but in here, I'm not initializing the parameter. Now we run all tests and it works. There's no problem. So our test passed. All our 4 passengers in our test are going to the end of the scanner. So this is good because then we can run the simulation again, and we can see how this is working. Perfect. Okay, let's add the last function to this model, which is the scanner. And we want to be sure that the scanner is following the distribution correctly again, and that the scanner is working properly. But we will test the distribution. That's what we're going to do again. So we don't need any new data. We'll need the model results. So we will create a statistics element here, private. So this statistic discrete is the same as what you see in the statistics palette, in the analysis palette, this object here. And this is what we're going to use. So what are the functions that we need? Public double scan meantime, and this will return sd.mean. And then public void set scan time. Let's call it add scan time. This will add to the stats whatever value we have here. So these are the functions that we will need. Then the scenario we don't need to touch, but we need to create a test. So let's add the annotation again, and let's create a function, test scanner time. Let's run the simulation for 10 minutes again, and we will need to do this again. So let's copy all this stuff. But now we change this to scanner time. Doesn't match expected. We'll add the 90 again here. We can erase this. We can run again the simulation 100 times. So the actual will be scan meantime, but I should put a get there. Get scan meantime. And the expected is scan time seconds. This is the expected, this is the actual. And here we do the exact same thing that we did before. But this is a normal distribution. So what do we do? The actual should be bigger than scan time seconds minus 1.96 multiplied by the standard deviation, scenario.gd.scan times standard deviation multiplied by this. But now our sample data is not sim time minutes. It's actually the amount of values I have in my statistics object. So here I can put root.modelResults dot, and I will need to add something. Or I can just quickly make this public so I can get access to it. .sd.count. These are the number of samples that we get. So now we add this here and a plus. I will count a success if this is the case, and I want maybe 90% successes. And we can add another condition here actually, because remember that the minimum should be 2. So we can add, now that this is public, dot mean bigger or equal to 2. So this is one of the conditions. Okay, finally, I think this is correct. And now we have to go back to run all tests to create our scenario here. So now we care about everything. We want to use the same values. These values don't matter for the purpose of our test, but these values matter. And we know that we have 10 as the mean and 2 as a standard deviation and 2 as the maximum. I will add a 0 here to have unlimited arrivals. Then again, scenario like this. we'll create a new unit test instance, and finally ut dot test scanner time, and that's it. Let's see if it works. Well, I guess I need to initialize this new statistics discrete, and this should work. And I'm dividing by 0 because I have no samples. So what I can use is zip this function that will be 0 if the result of the division is divided by 0. Okay, our tests can also have bugs. That's definitely possible. Okay, so now it's okay. Scanner time doesn't match expected, 95, actual 0, obviously, because we haven't done anything in the model. Now, let's go to the model and see what is going on. So in here, at the end of the queue, we will add a delay, which is the scan process. The capacity is only 1, we can assume, and the delay time will be normal, and in here we'll add the general data dot scan time seconds, general, this is the mean, general data scan time standard deviation, this is standard deviation, and before this we can put the minimum and the maximum. Scan time mean and infinity. That's it. Let's run it. Of course, it doesn't work because I'm not collecting the data that I need to collect. So how do we do this? Double time on scanner equals time in, let's be careful here because the airport model is defined in seconds. So this is in second minus agent dot get block enter time. This will return the enter time in seconds. So the value here is in seconds. And now model results dot add scan time, and here we'll put the value which is time on scanner, seconds. Now we can actually run the tests and no error, everything works perfectly fine. Awesome. And that's it. So we have this very small model with 3 particular tests.